So I've got a bit of an issue with my keyboard. It's been cleaned yesterday, and there's a bit of an issue here. See, if I press this key here, you can hear that lovely crisp Cherry MX Blue sound. And Windows key, still fine. But come over here to the control key. Very, very dissatisfying click. And so what I thought we would do today is try to fix this keyboard. This is a Cooler Master Quickfire XT, and I've already had it apart, as you can see. What I did was I cleaned the keyboard using by actually removing every single keycap and then cleaning those individually. This is spacebar is also pretty terrible, and this key is not great, sometimes sticks. Caps lock's gotten better, but was pretty bad yesterday. And I also had issues with the 8 and the E key in terms of contact. And I removed all the keycaps, and I took the PCB inside here and just used a brush to try to brush off all the dust that gathers down in here. And that was apparently not a good idea, because it looks like these switches have some dust in them. You can also hear the difference there. So I think what I'm going to do is I'm going to check all of these for the proper sound and feel, and see if I can show you how I disassemble it and how to clean them. I know other people have done this, but it's my first time doing it. I also have some new switches that I think will fit in case I can't recover these, but we'll be able to see how that's done as well. So I'm gonna try and clean up a working space over at the electronics workbench, and hopefully I'll have room for everything. Okay, so there's a couple of keys that are bad. There's the F6, F10, Tab, Caps Lock, Left Control, Space, and the right Windows key, this one. The right Windows key has been bad for a long while now, but I haven't actually bothered to look into how you might repair it. But let's see here. We have 6 different keys that are in need of service. So F6, F10, Caps Lock was the one that was really bad, and the Left Control and the Space Bar is also pretty dissatisfactory. You can tell it's sort of struggling to return. In case I didn't mention it, these are Cherry MX Blues, which are perhaps infamous for being somewhat difficult. They have the click in those switches comes from a free moving extra part in there, so it loses its click pretty easily if you get any kind of oil or dirt in there. So we're just going to head straight for the disassembly. This is an excellent screwdriver, by the way. It's the best Phillips driver I know of. It's the Vessel Megadora. I don't think it actually says Megadora on here anyway. But this is really good. It's got sort of serrations in the jaws here, so it really bites in. It's also fairly magnetic, so I'm not sure how I feel about that. Most of the time I'm not actually using magnetic screws, so it doesn't really matter for my own stuff. This assembly here is a bit tricky, but certainly doable. Just grab a my case, the back piece also comes off pretty easily. And you can see the construction. It's a metal frame here with a very simple one-layer circuit board on the back, and some of these key switches aren't sticking quite like they used to. This is the microcontroller. It does all the work as far as I can tell. Like that. So I think we're going to start with this control key down here. These keycaps are not sticking the way they used to originally. That's no good. So I'm going to start by removing the solder joints here, and then see if I can remove it properly. Oh, that was actually pretty easy. The holes in here are not plated through, which simplifies it greatly. They're also quite large compared to the pin diameter here. That means that you can just use some solder braids. If you're just doing a couple, you'd probably want a desoldering pump because there's quite a lot of joints if you were, say, replacing all the keys. And once you got it loose from the board, you can wiggle it around, and what you just need to do is sort of push on this with your finger, and then get some tweezers or something, and just push on this from that side. And you can just do one at a time, it seems, and it just popped right out. So that's it's pretty simple. Looks like this one has a diode across it. I'm gonna fire up the macro here so you can see. It has a diode symbol. Now here are the new switches. Ah, this one seems to be identical. The only difference is there's a noticeable difference in the sound, and what I'm also going to do is just fire up the old voltmeter here and check if there's any electrical difference between the two. I'm just going to measure ohms across the switches. So let's see, there's this one. Nothing in contact, and if there's a diode in there or something, then measuring the other way should show that. That looks fine. Measure the other one. This is the old one. And the electrical on resistance not bad, either one. It's measuring 0.16 ohms, which is fine. So there's not really much difference there. So yeah, I got these from Taiwan, and they seem just fine. Stop the macro recording there. So let's just see if we can pop this back in. Let's bend the pins a little. And these were for panel mount as well, so it goes in like that. And holes lined up. And I guess we can solder it. So, just gonna should really be all you need. You may want to clean up the flux or something, but that is probably not necessary for an application like this. Oh yeah. It's a little duller in terms of sound, but there is a bit of variance between the different switches here anyway. So, not a big deal, I think. Okay, so I've actually got the it loosened this switch here. What I did was I just used some pliers, like some tweezers like this, and I just put them in like that and bent up on either side. So we're gonna try to actually open this up now. See what's inside. In there. Not a whole lot of spring and spring here, really. There's a spring, it's reasonably well retained, seems fine. I'm gonna take a look at this in the microscope, and I'll get starting now. This might be a little hard to get on camera. I'm gonna see how close I can get on the macro here. Pretty close. I'm also gonna stop down a bit. There, I'm recording. I don't know if I'll be able to make this out. There are some hints of some contaminants on the sliders, which I think is where this white piece here actually moves. There's also some tiny trace amounts of dust in here that I believe might actually be enough to cause this thing to stop working properly. So I think what I'm gonna do is just soak this with ISO. Let's see, and if I just look up at the top shelf here, I have some of these little pins here, and I have a little bit of PRF 668, which is oil-free, should be good. But I think I am going to have to look into the microscope to do this. I think I'll just leave the recording running so you can have some commentary. This microscope, by the way, is an Amscope 3 to 20 amplification stereo, or binocular. It's quite good. It's probably the best microscope you can get for the money. It's got a good stand, boom stand. It's good. So I've just sprayed some contact cleaner down in there, and I'm just gonna wipe the wiper for the actual slider, just the white piece. That's what actually makes the noise, and I suspect that if that gets caught on something inside here, that will actually cause problems. So I think I've got the contaminants off. You can see a bit of wear on the actual elements, but I think the actual switching function shouldn't be affected. So let's see, I'm not going to use this soup. I'm going to use the cheaper ISO box to sort of spray this out. And some paper. Just to wipe stuff up with. I've seen someone online suggest using automotive brake cleaner for this, which I think is probably not a bad idea, actually. I don't see any real issues with doing that. Let's see, there's a little hair here. Grab some tweezers that aren't bent. And I just got the actual contact element out. There's a little bit of dust on there. Small wear marks. It's not really showing any indications that it's sticking or anything. So I think we're just going to spray this down and try to clean off any grease that might have gotten in there. And really, it's not like this thing's filthy inside. Where'd the spring go? I had it. There was a spring here. I saw it. You probably saw it roll away. here. Now we're gonna need to dry it out, probably. So I've got the Atten here, set to 280 degrees, which is a bit high, but I'll keep my fingers nearby so that way I can feel when it's getting too hot. And all the ISO will be evaporating. I can see it happening in there. It takes forever for this stuff to dry on its own, because it's enclosed. I'm actually going to remove this spring too. I think that's enough. I could turn the Atten down, but why bother? And yeah, my desk is not leveled, and that's because I have I have a little mat under the front legs. Let's see, it should go together like this. Oh yeah, put a keycap on it. Keycap seems to amplify the noise. So good. So good, that's all it takes. So refurbishing these switches, probably sensible if you have the time, or your time is worthless. But it's not super expensive to buy new ones either. So that's basically it. I think what I'll do now is I'll pop out all the remaining switches that that are not okay, felt off, and I'll probably just replace them, at least as a test. I'll replace all of them now with the new ones I got from Taiwan, and then I'll refurbish the old switches and put them back in this bag here. And you can tell them apart because they seem to have a slightly different code on the back. These are all labeled 231. And the old ones here are labeled 134, which might just be a lot code or something. Just do a quick comparison. So just bringing you very quickly back here for a little quickie here. If you're not familiar with soldering, the desoldering braid here has flux built in, which is important. If it doesn't have flux, it won't work at all. And the trick here, just to make sure you've actually desoldered it, is to look at it, but you should be able to just sort of grab it and see that the two pins here and this all sort of move together. Now it's desoldered. If you wiggle this and this one stays still, then that one still has probably a little joint here on the flat side. And sometimes you can just wiggle it a little and it'll break free. Other times you might even need to re-tin it and then remove it again in order to actually break it loose. But with a circuit board like this, which only has etching on one side, it's usually very simple to get these out. There's no plating inside the hole that will also be soldered. Okay, so I got the keyboard all back together again. It's all working very nicely. I did that off screen. I've tested it. I replaced one more key than I had planned to, because I remembered I had some contact issues with those two keys yesterday. So I just replaced those as well. Now not all of these had the exact same symptoms. Some of them did click, but were very slow on the return. And this one I put aside because this one actually failed before I did my failed cleaning attempt. So I'm a little excited to see what's going on there. There's sort of potentially signs of oil on the contacts. Let's take a look at the maybe plastic or metal chips. It's hard to see if there's oil in there, but there's also one piece of hair. I didn't label these switches, so it's kind of hard for me to say exactly what the symptom was for each of the switches I'm taking apart here. there's definitely oil in this one. I can see it sort of spreading out, sort of smearing it about here. And I think it helps to just spray everything down a bit, just sort of wash off it. Like if you dissolve stuff that's on the surface, if you don't wash it off, it'll just re-solidify. When your solvent evaporates, it'll still be there. It's not going to go away. So I'm just going to batch these up, I think. And like, they're all the same, so it shouldn't matter which one goes where. There mainly seems to be this sort of fork section in the front here. That's these two surfaces, and the copper spring, the beryllium copper spring they ride against. That's going to be the main problem. Just give that a soak as well, and a bit of a spray down. And I think I'll visually inspect all of these before reassembly as well. Okay, now here's where it gets interesting. This one failed basically on its own. Though I think there were some crumbs inside the keyboard at that time. That may have been ground up into a sort of flour, basically. There. Let's see, spring. This one has a sort of drier coating. So I don't know why this one failed prematurely, probably just pure chance. It's interesting, it's almost like there's pitting on the sliding elements. But yeah, I'm trying to clean these now. If I can't clean them or get them working again, then I'll probably just throw them away. Yeah, this is interesting. It's almost like there's been a sort of corrosive or like a sanding compound in there that's caused the... It could very well be. It might be sand. It might have actually caused premature wear on the contact surface, sort of causing these elements to stick together. There. We'll see if it's repairable or not. Now these will go together in somewhat random order, but this one appears to be dry, this one appears to be dry, and this one. So here is my baggie of switches, new and old. I ended up throwing away 2 of the switches I was going to clean. One because it wouldn't click, and one because it would get stuck in the down position. You could probably repair those if you needed to, but since I have these, I'm glad I did. I would certainly recommend just buying new switches if you're gonna repair a keyboard instead of relying on refurbishing them. You should have a buffer of sorts. But yeah, I'm quite happy with this, and